Good morning. This is really just a continuation of the conversation we had during our live lesson on Wednesday. So, about half of you were at the live lesson. If you were not there, you absolutely need to watch the video. Otherwise, you will have no idea what's going on. Not that it's difficult, just confusing until you see it. So, we've been talking about combining random variables. So, let's remind us where we were. If we have a random variable and we know the mean and standard deviation, if we're just gonna, and we talked about playing these carnival games where we had prizes and probabilities, that if we're just gonna triple the value of the winnings, like take a random variable and multiply it by 3, then not surprisingly that the mean would multiply by 3 and the standard deviation would multiply by 3 and the variance would multiply by 3 squared, which is 9. So that was the result of multiplying a random variable by a number like 3. And the other part of that linear transformation was if we just took a random variable and added $7 to each of the prizes, the mean would go up by that 7. The standard deviation and variance would not change at all. So that was the first conclusion. And then we talked about combining random variables. We had game A and game B. And what if I played game A and then game B and then added the winnings together? And remember that the mean of A plus B was what we expected it to be, the mean of A plus the mean of B. But then what the important conclusion that wasn't obvious was that the standard deviation of A plus B was not the sum of the two standard deviations. Remember, the standard deviations did not add, but the variances did add. So the variance of A plus B was the variance of A plus the variance of B. And then you could square root that to get the standard deviation of A plus B. And then lastly, we talked about the difference, A minus B. Let's play game A and you win it, and play game B and you lose it. So again, not surprisingly, the mean of A minus B was the mean of A minus the mean of B. But what we a little surprisingly found was that the variances of A minus B, it still added, even though it was differences. So the variance of A minus B was still the variance of A plus the variance of B. And then you still square rooted that to get the standard deviation. So that's kind of there's your summary of the video from Wednesday. Okay. The last part of the conversation, which there just wasn't quite enough time for on Wednesday, is about this. It says warning. First of all, there's a typo here. I apologize. It says warning. With random variables, A plus A does not equal 2A. Algebraically, that's a stupid inequality, but it's true with random variables. So here's what I want to do. I want to go back to the same game A we talked about on Wednesday, and here's just to remind you, there's game A. He's either going to win $4 or $10 with probability 0.8 or 0.2, and then we use the calculator to find the mean. Turned out to be 5.2. The standard deviation was 2.4. The variance, which is just the standard deviation squared, was 5.76. So we had that information the other day. So I want to talk about two people going up to this game and doing different things. And the question still is, what are the mean and standard deviation of whatever they're doing? So the first one is Billy. Billy plays game A once, but he's going to double the bet. So I define this random variable B equals 2A. So I'm just playing it once, but instead of winning either 4 or 10, I'm just doubling my winnings to either 8 or 20, which is where this comes from. There's my 8, there's my 20. Probabilities stay the same. And remember, this kind of did what we thought. The mean, in fact, would be, and over here on the right, there's my original information about game A, just so we have it in front of us. So the mean of B would, in fact, just be 2 times the mean of A. So since the mean of A was 5.2, which is over here, the mean of B would just be 2 times that, which is 10.4. Standard deviation was just 2 times the original standard deviation, which is 2 times 2.4, which is 4.8. And then, of course, the variance would just be 4.8 squared, which is 2 squared times this 5.76, which is 23.04. So that's just a linear transformation, taking game A and multiplying it by 2. And the conclusions that you need to know happen, which are fairly intuitive. The mean gets doubled. The standard deviation gets doubled. If the numbers are twice as big, then how spread out it is twice as big. Excuse me. And then the variance is just the standard deviation squared. So that's not tragically Surprising. Again, that's Billy. He only played the game once and he doubled his bet. So B was 2A. Let's compare that to Carol, who plays game A twice and adds her winnings. So she plays game A, either wins $4 or $10. Then she plays game A again and wins either $4 or $10. The question is, what are the mean and standard deviation of that sum? So here I have defined the random variable C as A plus A. Notice my winning potentials are not just 8 and 20, because I could win 4 and 4, that would be 8. I could win 10 and 10, that would be 20. But I could also win 4 and then 10 in the 2 times that I play, or 10 and then 4. That's where this potential winnings of 14 came in. And remember the other day I made a tree diagram to find those probabilities. I need to show you that when you know the conclusions, you don't have to go through those probabilities. So I'm trying to now find the mean and standard deviation of A plus A. Well, first let's find the mean. And there went my camera. And the mean of A plus A is still what you would think. It's the mean of A plus the mean of A, which is 5.2 plus 5.2, which is 10.4. That's the expected value of her winnings if she plays game A twice. And that is the same as it was for Billy. The mean for Billy was just 2 times 5.2, 10.4. So when you compare 2A to A plus A, the mean does not change. They were both 10.4. But how spread out the data is, which is what the standard deviation tells us, is different. And before I do the math, I want that to make sense. If I go back to Billy, I'm either winning 8 or 20. Those are the only if I'm just doubling the bet, I'm either winning 8 or 20. And we're calculating how spread out that is. The standard deviation was 4.8. If I talk about Carol, now I don't only have 8 or 20 as possible winnings, I also have 14, which is kind of in the middle of 8 and 20. So I think it should make sense that this one should maybe be a little less spread out, because there's some values. It's not only the extremes of 8 or 20. I also have that 14 in the middle. So I think it should make sense that the standard deviation of this should be a little smaller. But again, the rule here, since this is A plus A, remember the variances add when you add 2 random variables. And my variance for game A is over here. It was 5.76. That was the variance of game A. So when I do A plus A, the variance of C, and notice you have to calculate the variance first before you calculate the standard deviation. The variance of C, and here's my picture of the way here. The variance of C is the variance of A plus the variance of A. And there's that 5.76 plus 5.76, which is 11.52. That's the variance of game C. And then to find the standard deviation of game C, I just have to square root that number. So I square root 11.52, it turned out to be 3.39. So the standard deviation of game C, where I played game A and then played game A again, was 3.39. Compare that to Billy, where the standard deviation was, 4.8. So just be real careful as you are reading these problems and wondering, am I just doubling something or am I adding it together? That those are not the same phenomenon as far as finding the standard deviations. The mean would be the same, but not the standard deviation. Okay, so that was kind of the end of the lesson from Wednesday, and I'm going to stop there. There's one more piece to section 6.2, and that video will take place on Monday, assuming we don't get more snow, which I don't think we're supposed to get. So your first assignment in section 6.2 is right here. Again, watch the video if you haven't from Wednesday, and this video should help you do that. And I think what I'm going to do this time, I'm trying to be helpful, but not help you cheat. I'm going to make this due Monday night, and I think I will post solutions to this on Monday, because this is one of these things that I want to make sure you understand as you're doing it or before you turn it in. So just to help you, that is kind of my plan. So there you have it. Have a great Friday.